So regression finds a function from a specified class, here f sub r, that best fits the data. In this example, the squared error criterion is used to measure the goodness of the fit between the function and the actual training data. What is linear regression? Does linear mean that only linear functions for f are considered? That would be very limiting, and that's not the case. So what is linear regression? Linear regression means that the function space, fr, is a linear space. What do we mean by that? Well, concretely, the user, the person doing the fitting, specifies a finite number, I'll call it n sub b, of functions which are called basis functions. And for the purpose of this lecture, we'll label them phi1, phi2, up to phi sub nb. And fr is defined in terms of these. Fr is the set of all functions that can be obtained by taking linear combinations of these basis functions, namely expressions like this: a1 times phi1 plus a2 times phi2 plus an times phi nb, where all the ai's are real numbers. For example, suppose there's three basis functions: the basis function 1, the basis function sine of x, and the basis function x squared. Then f sub r would be all functions of the form a1 plus a2 sine x plus a3 x squared. Notice these themselves are nonlinear functions of x, but they're linear combinations of the basis functions. And that linear combination of the basis functions is what is referred to when we talk about linear regression. The specified class of functions, f sub r, that we will do our search over is defined by a finite set of basis functions and is all possible linear combinations of those basis functions. Understanding this is important. Let's do a small quiz.